How did these clips ever get into production? Hey, this is Pedro Munoz, and today I'll be talking about the top 5 most ridiculous physics blunders in movies and shows. Please be advised that this clip contains situations of such absurdity that you might faint.
And here we go.
Number 5. Bus jump. Speed. Conceptually speaking, what is going on here is an issue pertaining to projectile motion. Somehow the bus's horizontal velocity overcomes its vertical downward velocity. Being it is a two-dimensional situation, both the horizontal and vertical velocity are independent of each other. In order for the bus to actually land, the other end must be lower than where the bus drove off of, or there must be an incline. Let's see how low the other end should have been in order for the bus to land. We know that the bus was going 67 miles per hour, or about 29.95 meters per second, across a 50-foot gap, or 15.24 meters. We solved for time using the Novi final formula, giving us a time of about 0.5088 seconds. Since time is related in both directions, we use it in the following formula to see how low the other end should end up to be. And we get about 1.270 meters below from where it dropped. Number 4. Truck flip. The Dark Knight.
Oh, you want to play? Come on. Come on. He missed!
In this clip of The Dark Knight, it represents Newton's first law in a bad way. The truck is caused to flip from a wire that thin. The truck is exerting a force from a mass much greater than the tension of the said wire can withstand. In reality, the truck would have obeyed Newton's first law of inertia to stay in motion unless acted upon by an unbalanced force, thus meaning that the truck would have continued driving and causing the wire to snap. Number 3. Train scene. Spider-Man 2.
We're slowing down.
The average mass of a subway in New York City is about 38,000 kilograms, and in the film the train goes to 80 miles per hour or 35.76 meters per second. It took your friendly neighborhood Spider-Man 75 seconds to stop the train. Using the impulse momentum theorem, we can solve the amount of force needed to stop the train, which when calculated is about 18,120 newtons. Now, most of you might be thinking, he's a superhero, that's what he can do. Yes, he is one, but actor Tobey Maguire is only 160 pounds, or about 712 newtons, and the average spider could exert forces of 8 times their weight, meaning that he could exert only about 5,696 newtons, which is much less what is capable of stopping that train. Number 2. Another train and hero. Hancock. This is another case of heroes breaking physics, where in this case the third law of motion stating that every action force there is an equal and opposite reaction force. Even if our hero here, Hancock, can stop the train, he would experience a greater acceleration backwards due to him having a smaller mass, rather than him staying in place like in the clip. What would truly happen is that the train would slowly descend because it has a smaller acceleration because of its large mass, while Hancock goes flying backwards. Number 1. Wile E. Coyote Cannonfall, Looney Tunes. This clip is an issue of the conservation of momentum. The cannon, being of larger mass, will have a smaller velocity due to it as stated in the conservation of momentum theorem. Assuming the coyote is 35 kilograms and the cannon as 900 kilograms, and as well as the muzzle velocity, about 539.2 meters per second, we can find the velocity of the cannon going backwards. The initial momentum must equal the final momentum, which is the reason why it's crossed out and equals 0, because both of the objects start off at rest. That means the momentum of each object after firing must be equal and opposite to each other. And when solved, we get a velocity of about negative 20.97 meters per second for the cannon, which is clearly what does not happen within the clip.